2016 O-Level, Science Part 2, Structured Papers, question number 3 I'll be discussing here. This is on chemistry. Let's see how the question is. As shown in the following figures, magnesium chloride, sugar, grease are added to the test tubes A, B, C, D and E. After that, the substances in the test tubes are stirred well, right? So then we can identify in test tube A, magnesium chloride and distilled water there. In test tube B, distilled water and magnesium chloride. Test tube C, sugar and distilled water at 25 degrees. Test tube D, sugar and kerosene. Grease and kerosene they are in test tube E. Let's see what they are asking in this question. Roman number 1, A part. In which test tube a solid liquid heterogeneous mixture is formed? We can understand all of these, the solutes are solid, so that means magnesium chloride, sugar, at the same time grease, all three are in solid state. When it comes distilled water, it is in liquid state, so then there's no doubt all of them are solid liquid mixtures. But when it comes to a heterogeneous mixture, we know there are two types of mixtures when it comes to mixtures. Those are heterogeneous and homogeneous. Out of them, what do you call heterogeneous? That means if we consider the complete mixture, throughout we can't identify the same concentration, same color we can't identify. At the same time, same taste also won't be there. So then that type of mixtures we consider as heterogeneous ones. Now let's consider out of these which one is heterogeneous. When it comes to test tube A, it consists of magnesium chloride and distilled water. Magnesium chloride is an ionic compound. It dissolves well in water. So then the same thing we can apply for test tube B also. So then the answer can't be test tube A or B. When you move on to test tube C, it consists of sugar and distilled water. Sugar is a polar solute and distilled water is a polar solvent. So then sugar will dissolve well in distilled water. We practically know that. So then the fourth one, or else test tube D, consists of sugar and kerosene. Sugar is a polar solute, but kerosene is a non-polar solvent. So then sugar cannot be dissolved in kerosene. We know that. We'll keep that and we'll move the next one also. Then we'll come back to the answer. So then grease is a non-polar solute and kerosene is a non-polar solvent. They'll dissolve well. So then the answer has to be test tube D. So then in which test tube a solid liquid heterogeneous mixture is formed? In test tube D. Right, B part. Right, respectively the solute and the solvent. So when it comes to the test tube D, the solute has to be sugar and the solvent where the excess amount of which consists of in this the mixture, that is the solvent, that is kerosene. Right, problem number 2, A part. Define solubility of a solute. When it comes to solubility of a solute, we have to consider the mass of a solute which dissolves in 100 grams of solvent at a certain temperature. I'm not going to write that. The key points I have to mention: the mass of solute which dissolve in 100 grams of solvent in a certain temperature. Why we consider a certain temperature specially? Because when the temperature changes, the solubility of a solute also changes. So then I'm not going to write the definition. As I said, those are the key points you have to mention there, right? So we'll move on to B part. What factor that affects the solubility can be shown by each of the following pairs of test tubes? We understand when it comes to the solubility of a solute in a certain solvent, we consider 3 factors mainly. What are those 3 factors? First one is temperature, second is the nature of the solute, and the third one is nature of the solvent, right? Let's see A and B, what's the factor they'll be considering. You can clearly see same solute, same solvent they are using, but they have changed the temperature. So then A and B, temperature is a factor they'll be considering. When it comes to C and D, they have used the same solute, and they'll be having both of these C and D test tubes at the same temperature also, but they have changed the solvent. So then C and D should be nature of the solvent, right? So then when it comes to D and E, they have used same. They have They have kept both of the test tubes in the same temperature at 25 degrees, and they have used the same solvent, but they have changed the solute. So then it has to be nature of the solute, right? Now we'll move on to round number 3. In the above experiment, 1.9 grams of magnesium chloride was added to test tube A and the total volume of the solution formed was 10 centimeter cube. Find the number of moles in magnesium chloride added. So then we have to find the number of moles. So then for that we have to use a relationship N equals M over M. That means number of moles equal to mass over molar mass. First of all, we have to find the molar mass. Now it is magnesium chloride. The molar mass should be 25 plus 35.5 multiplied by 2 has to be 95 grams a mole, and the mass they have given, that is 1.9 grams. So then we have divide 1.9 grams by 95 grams a mole, 0.02 moles. B part, calculate the concentration of magnesium chloride in the solution. So then when it comes to concentration, we understand we have to consider the number of moles we have divided by the volume. So then we'll be getting the answer. The number of moles you already got in the previous part, 0.02 moles we have divided by the volume, 10 centimeter cube. So then you can write the answer 0.002 moles per centimeter cube. We don't express the concentration in these units. Moles or centimeter cube we won't be expressing in. So then we have to convert that to moles or decimeter cube. So then I'll be converting that in 10 centimeter cube. We can identify 0.02 moles. So then 1 decimeter cube means 1000 centimeter cube. So then I have to convert to in 1000 centimeter cube, how many moles are there in magnesium chloride. So then when I convert that, I'll be getting 2 moles a decimeter cube. Why did I do that? Because usually when it comes to the concentration, we don't express in moles centimeter cube, we have to express in moles decimeter cube. Right, round number 4. Water is a good solvent. Write 2 special properties possessed by water due to intermolecular forces. What are these intermolecular forces? We understand when it comes to water, we can identify the water molecule like this. Oxygen will be there like this, and hydrogen atoms will be there like this. Due to the polarity between oxygen and hydrogen, there will be delta minus, they'll be gaining delta minus and delta plus small charges like this. This happens exactly due to the electronegativity difference between oxygen and hydrogen. If there will be another water molecule close to this one, what happens? There will be attractions forming between these 2 molecules. So then we can identify like this, these attractions. So then due to that, there will be different properties gained by water. One of them, the boiling points of water has increased. At the same time, the specific heat capacity has increased. Density of water is greater than ice. So then one of those properties you can write as those 2 special properties gained by water.